Okay, so let's get started now. So now we also looked at in the not in the last class, the class before that, we looked at what is known as the subspace, right? So what is a subspace? If you take R2, R is a subspace, right? If you take R3, R2 as well as R, both are subspaces, right? So what are the properties of a subspace? Suppose you have a set U contained in V, right? V is a vector space over R or C. And I say that U is a subspace of V. When do you say that? First of all, it should be contained in V, right? So it should sit inside V. And then it should be closed under linear combination, right? So if you take any two vectors and alpha beta, if you take alpha beta linear combination of those two vectors, it should belong to the set, right? Closed under linear combination. Okay. So now let's look at a particular set. Okay. So let you take a matrix. Okay. I'll take a very general matrix, which is M cross N, right? This is an M cross N matrix. Now I'll take the following set. Okay, so I'm going to look at all those X in Rn that gets mapped to 0 under A. So okay, so what is this set? Can somebody think of what kind of set this is? So it is that portion of Rn or the vectors which gets mapped to 0 under A, right? So pictorially, this is how it looks like. So for example, this is your Rn. It gets mapped to Rm, right, under A, because it's M cross N. If you write multiply by X, you get an M cross 1 vector, right? So it gets mapped to Rm. Now 0 is sitting somewhere here. So this is your 0. Okay. So there is some small subset here of vectors which gets all of these vectors get mapped to 0, right? So obviously this is a subset of Rn. Do you agree with this, everyone? Of course, it is all those vector in Rn that gets mapped to 0. Therefore, it's a subset of Rn.